Today we are going to discuss about new things that is called electromagnetism. So first I'll tell you that how the things has come into the mind of the human being. So before 1820, the magnetic effect and the electricity or electric effect, or you can see electricity and magnetism, was known to human being. But it was not known that they are also related to each other. So in 1820, the Danish scientist, the name Hans Christian Oersted, was doing one experiment with the heating effect of electric current. And at the time of experiment, there was a compass on the table, and the compass was under a electric wire. And when he switched on the circuit, he observed that the sudden deflection in the compass. Actually, he was doing some other experiment, but he observed that the compass deflected in a particular direction. So he noticed that one, and because it was a completely new thing, it was an accidental invention that when the current is passing through a compass, so it will deflect. So from there he started doing experiment on that. In 1920, he firstly demonstrated that both electricity and magnetisms are intimately related to each other, and this led to the unification of the electricity and magnetism. So the new branch started. So the branch of physics, as a result of an unification of the electricity and magnetism, it is known as the electromagnetism, and thus the electromagnetism is due to the electric current in a conductor is called the electromagnetism. So first we will learn today what is electromagnetism. The magnetism due to the electric current in a conductor is called electromagnetism. So the relation between electricity and magnetism has been established. So now today we'll only discuss about the Oersted experiments, what Oersted was observed in his experiment. So we'll discuss about the three observations what he was observed. So he did a simple experiment. So we are going to draw the diagram of the experiment. So we'll write here Oersted's experiments. So we'll draw a simple diagram here of the experiment. So here is one battery connected. Here is one variable resistor. And here actually here is a compass. The compass is on the wire. Okay, the compass is on the wire. So now I'm going to draw this with the compass. So wire is here. So wire is going under the compass. Now here is one switch. You can understand the current is going in this direction. and this is the north pole of the compass. This is the north pole of the compass. So also I can mention here which one is north, south, east, west. So this is your north, this is south, this one is east and west. Now similar diagram also will draw when the battery will be in opposite direction. So same thing. And the switch is there, K switch is K here. So the battery, the current will go in this direction, in this way, and the deflection will be here. So what he observed? He observed that when a sufficient current was allowed to pass through a wire AB, so this is the wire AB, placed along the axis of the magnetic needle, okay, because the needle was like this. So when the current will start to flow, the needle will bend like this way. So when the sufficient current was allowed to pass through wire AB, so write down this one, you can understand this one. When sufficient current was allowed with wire AB placed along the axis of the or of a magnetic needle. Kept directly below and close to the wire. So what he observed, the needle has been deflected. Okay, so you can write the needle was found to deflect. Deflect from its normal position. So meaning the needle was like this. When you switch on this key, the needle will deflect in this way. Okay, so that was his observation. So what was the next observation? So next observation is quite simple. So the deflection of the needle was found to be in opposite direction. So write down the deflection of the needle was found to be in the opposite direction on reversing the direction of the current. Okay. So how you can change the direction of the current? You can just change the polarity of the battery, so direction of the current will change. So as the direction of the current will change, the needle will deflect in the opposite direction. So here it was deflecting in this direction when the current was passing in this way, and when you change the polarity of the battery, so this one is minus, this one is plus, and this is plus, and this is minus, so deflection will be in the other side. So this is your north pole, this is also your north pole. Okay, so this thing will happen. Now, third one, he observed that if I increase the amount of current, how we can increase? We can change this resistance value. So we can increase the current. If I increase the amount of current, the deflection will also change. So the deflection of magnetic needle changed with the strength of electric current. The deflection of the needle increased with the increase in current. So these are the things he observed. So this is a very remarkable invention, and also the invention was an accidental invention. So after that, Maxwell, Hertz, Bose, Marconi, and so many like scientists worked on the findings of the Oersteds, and they carried out many experiments and proved that the law of electricity and the law of magnetism are verified. Okay, so we're going to discuss about the Ampere Swimming Law. So it is a very interesting law. So Ampere swimming law is, suppose this is a wire here. I'm going to draw with a red pen. This is a current carrying wire here. Current is passing in this direction, and a man is swimming here. This is the direction of current. You can write direction of current. Suppose a man is swimming here. I'm going to draw a man here. So the person is swimming like this way. Okay. This way. So Ampere said that imagine a man who swims along a conductor in the direction of the current facing the needle, such that the current enters his feet and then north of the needle will deflect towards his hand. That means that suppose the person is facing towards this wire, and the person is swimming towards the direction of the current. So the left hand, which direction the left hand of the swimmer will be, in that direction the needle will deflect. So if I keep the needle here, if this is the original position of the needle like this way, parallel to this wire, the needle will deflect in this direction, the left side, this left side of the swimmer. That means the needle will be in this position. When you send the current here, the needle will deflect in this direction, okay, in this side. So left side of the left hand of the swimmer. Okay, so the Ampere Swimming Law is also known as the snow rule, which indicates the capital letters in the sentence. If current flow from south to north in a wire kept over a magnetic needle, the north of the needle will deflect towards the west. Okay, so if you write down here the snow rule, snow. Or is said that if current flows from south to north, this is the S, capital South, so snow S, south to north, N, this is N, south to north in a wire kept over a magnetic needle over this O, over the north of the needle, the north of the needle will deflect towards west, right here. West is W here, W is west. So which one is the main words of the snow? So first one is this S, south, then north, then O, and then SNOW, then west, this one. So remember, this one is very important. So what we learned, I'll give you one brief. So when the current will pass through a conductor, the magnetic field will produce, and it is like what are the Oersted also observed these things. So if we change the direction of the current, the deflection will also, the direction of the deflection will also change. And also we learned the Ampere swimming rule. So what is the Ampere swimming rule? A person is swimming towards the direction of the current, and a needle is kept under the wire with the same direction of the current, not pulling the same directions. So when we switch on the current, what will happen when you switch on the circuit, then the deflection of the needle will be in the direction, the left hand side of the swimmer. Okay, so that is the Oersted experiment, and also introduced about the electromagnetism. So thank you very much. Next class will continue with the nature of the magnetic field.